Thank you so much. Well, it's lovely to see you all. I mean, I can see you. I've got like a little screen where I'm able to see what you all look like, which is great. Thank you for the wave. That's that's good. I was hoping to be with you in person, but I'm not going to say why, but just due to factors. There are factors involved with why I can't be with you in person. So we thought, well, rather than me not being able to share anything with you, let's do the next best thing and do this remotely, because we are in the age of, remote working and everything else. So hopefully you can see my screen and we're all good to go. And so let's push on and talk about why you may not need your own servers in the future. And I know for many of you, that is a scary, scary proposition. As mentioned, I wrote a couple of books. If you want to know more about them, you can find that information out on the internet. Just to let you know, the second edition of Building Microservices is now out, even though it seems that lots of people have copies of it, apart from me, the person that wrote the book. The talk today is split more or less into 3 sections. I'm going to try and keep it fairly brief to give as much time as possible for questions, because I know some of these ideas might be a bit controversial. But first off, we're going to talk a little bit about the cloud and serverless landscape. We're then going to look a little bit at how microservices might work within the context of functions, and specifically function as a service type offerings, which is an interesting part of serverless computing. Because microservices being my thing, it would be weird if I didn't at some point mention microservices. And then we will talk about, well, with all this information, what do you do about this? What activity can you make in your day job or in your personal life, maybe not your personal life, to take advantage of some of these ideas? But let's start off by talking about the landscape of cloud and the serverless. And I think the first thing I want to say here is it's pretty clear to me that we are still in love with our machines. And I mean that in the physical sense of machine, not the virtual sense of machine. We seem to be in love with our hardware. I am surrounded by bits of kit here. I've got a Raspberry Pi cluster I'm building in the corner. I don't need a Raspberry Pi cluster. Nobody needs a Raspberry Pi cluster, but I am building one. But your companies are probably also still in love with their own physical machines. If you take a look at the data from IDC, they sort of every quarter or so update their understanding about where money is being spent in the infrastructure space. And as of sort of the end of last year, 65% of all spend in IT is sort of on-prem spend. Right. So that represents a combination of both traditional sort of data center spend, which is by far the biggest proportion of spend. We still spend way more on-prem spend than we do public cloud. So that combination of private cloud and traditional data center spend is still vastly outweighs public cloud spend. And that hasn't changed actually much. We sort of saw a big flattening around 2000, from 2018 till now, in terms of the proportion of money going into public cloud versus private cloud. It's almost like the rush to public cloud sort of seemed to slow. Although that's not the whole picture, because in general, we're spending more money every single year. So even if you didn't spend any more or proportionally on public cloud, the public cloud pie is still growing bigger. And so they're looking forward, and they've been tracking these stats for many years. And according to IDC themselves, and of course, I cherry-picked their stats because it reinforces my own argument, like any good scientist, we can see that they're seeing that private cloud spend is going to compound increase about 9%. In that same period, they're seeing that public cloud forecast is only going to grow about 6%. So this is kind of interesting, right? So this idea that everyone is rushing to public cloud isn't really true. What's actually happening is we're spending more and more money every year on private cloud infrastructure and kidding ourselves that your rubbish private cloud is anywhere near as good as the public clouds that are available to us. So yes, public cloud is growing, but not as fast as private cloud. And I still, because of this sort of interesting trend, I sort of have this feeling that rather than the machines working for us, we're somehow working for the machines. We seem to be trapped in this tar pit of owning our own physical infrastructure. And things like Kubernetes allow us to keep indulging this sunk cost fallacy that we should run this stuff ourselves. Now, to give you a very brief overview of history, I'm a little bit older than I look. Not a lot older, don't insult me, but I have been around, a while, and I to see a few trends, not a lot, but a few. And obviously, once upon a time, all of our software was running on physical infrastructure, and sort of in the late 1990s into early 2000s, virtualization transformed the traditional data center game. Suddenly, we could take a physical machine, which was maybe having fairly limited utilization because it was only being used for one purpose, and now we could break that apart into lots of virtual machines. This allowed us to get a lot more utilization out of our hardware, be much more flexible in how it used it. And look, in general, virtualization is freaking awesome and arguably has done quite a bit for the environment because it's allowed us to actually make better use of the equipment that we've got rather than keep having to buy more equipment because we could only isolate resources based on physical computing workloads. It's sort of also interesting to note that kind of a lot of the stuff we sort of thought was so fantastic about virtualization, arguably mainframes already did 20 years earlier, but I digress. So this became interesting. Virtualization was going well. And then, of course, we started having late 2010s. It was late 2000s, so early 2010. Public cloud started becoming more popular through AWS. And the infrastructure as a service space started taking off, taking that virtualized infrastructure and making it a public service that you could rent on per the hour, rather than still having that kind of ongoing sunk cost of your physical infrastructure. And so around the 2010s, a project called OpenStack emerged. And OpenStack was the idea that you can take your physical infrastructure and put a layer of infrastructure as a service type automation on top. So the promise at the time was, for many of the vendors in this space, was you see what you can do with Amazon and all their fantastic APIs they give you to allow you to control your virtualized compute, networking, and storage. You see how brilliant that is? Well, you've got all these machines. We'll give you OpenStack, and you're going to get AWS on-prem. That was honestly a lot of the spiel that was put out at that time, which looks even more laughable when you look at it now. And OpenStack, for many reasons, didn't really work, but that didn't stop, our IT industry putting tens, if not hundreds of millions of dollars into trying to create internal infrastructure that would give us something like the power of a public cloud provider. And it didn't really work out so well. But it's okay because now, of course, we have Kubernetes. And Kubernetes is going to allow us to basically have something as good as a public cloud on our own private infrastructure. And maybe looking back at this, you might think, okay, well, we're getting better, right? We're advancing. We've gone from virtualization, and then we've sort of played around with OpenStack, and now Kubernetes is going to allow us to have everything we want. And I think in reality, for many of us, is that this is less of a giant leap forward and evolution in terms of our private cloud environments, and more a migration from one kind of bacteria to a slightly different type of bacteria. Look, don't get me wrong, Kubernetes is amazing, and it's done a brilliant job at creating a common set of APIs onto which we can put many, many different tools. But, of course, when you want to build your own private cloud platform on something like Kubernetes, Kubernetes itself is not a platform, right? Kubernetes itself is a container scheduling tool for running across multiple machines. You make it a platform by all the things you then have to put on top. And when we talk about all the things that you're going to have to put on top, oh boy, oh boy, oh boy, oh boy. We've all been to the cloud landscape, and look, there are some brilliant things in this space. Awesome, amazing things, some great technology. But let's talk about the tyranny of choice here. You start looking at this, trying to assemble your own great private cloud experience. And the very first thing you see is a little link at the top. You see this page and you go, yeah, I am overwhelmed. And then you see this little notation at the top. It says, look, if you're feeling overwhelmed, we've got a special trail map with an interactive web-based system to help you navigate this landscape. And of course, you see that and think, okay, great. But they say that, but what we hear is, okay, I'm going to need to get some consultants in now and pay a lot of money, probably to IBM. Weirdly, I don't know how they're still in the game, but nonetheless, they're going to get a chunk of our money, and maybe even Larry Ellison. Why would somebody who does an okay database suddenly think that they can run your private cloud? But they think they can. So strap in. When you run your own private cloud, you have to accept that you're taking on board all of the work you originally had to already do and a load more stuff besides. So if your existing traditional data center experience wasn't that great, you've somehow got to convince yourselves that despite not doing a great job in the past, you're now going to increase the complexity of those stacks significantly and do a better job. Because let's talk about what you've got now. That underlying hardware, that's yours. That's yours to keep. Then you're going to have an operating system on top of that hardware, which of course you have to manage and patch. Then you've got the hypervisor that's going to be sitting on top, which does the vising in a hyper fashion, which obviously does all the virtualization isolation. Then you're running the virtual machine operating system on top, which again, you're running. Then you've got your container runtime. It's probably not Docker anymore, but you get the idea. And then you're running your container operating system on top of Docker, because remember, you have a full operating system inside your containers, which some people seem to forget about. And then you've got your application that sits on top. And this is a simplified stack because I've taken out Kubernetes. And when you run a full private cloud stack, this is yours. You own it. How much confidence do you have that every single layer in this stack is being looked after well? Do you know that all this stuff's being patched and maintained and monitored? And a lot of time in organizations, these different layers will be managed by different parts of your organization. And of course, we all know what happens when you've got lots of different layers in an organization, all with siloed responsibilities that somehow still have to work together to deliver a useful product. And of course, this is the promise of us using public cloud resources, is that we can offload a bunch of responsibilities. When we use the cloud infrastructure as a service type offerings, compute, cloud, networking as the basic fundamental primitives, we effectively get to offload everything from the hypervisor down when we think about it from a compute point of view. So we're pushing responsibility to other people that we hope can do a job better than we can. And by and large, that's the case. If we move into the world of using container platforms on the cloud, ECS, AKS, EKS, whatever KS you want, again, you're offloading more work and responsibility. And this is attractive. So this is why a lot of people will, like if they're adopting, say, we're going to use Kubernetes, we'll use a managed Kubernetes provider because we're offloading more and more work. And that's limiting the stuff that we have to worry about. Again, just remember that little container operating system. I mean, you've just probably seen Liz Rice do an awesome talk about this, so you'll be aware of what the challenges are in that space. And then, of course, we have serverless, and enter another buzzword. Fundamentally, a lot of people have distilled serverless down into being serverless means function as a service, but it means way more than that. And in fact, the term serverless predates the concept of function as a service by at least 2 years. But fundamentally, a serverless offering is something that completely abstracts away the underlying notion of machines. Yes, of course, there are computers running serverless offerings, but there are things that you, as the end user, are completely hidden from. And that's not something you get with, say, Kubernetes, when you're working with vanilla containers. And that's not the fault of Kubernetes. It's not what it's designed for, but you're still dealing in terms of, memory and portions of CPUs and number of instances and that sort of stuff. With serverless offerings, you're not managing the server. All of these serverless offerings, they're going to auto scale based on how you use them. So you're not having to predict your load quite as much. It's going to react more dynamically. Implicitly, these are things that are assumed to have high availability. And this is obviously one of the things that public cloud vendors tend to be pretty good at. And when you're in a situation where you are paying for these things, they are pay as you go and pay based on more specific usage. And if we look at some of the serverless offerings out there that give us these kind of capabilities, we've got function as a service, we've got various different messaging solutions, there's a lot of different types of database, and of course, storage. Interestingly, if you look at the first two products released by AWS back in 2006, they were Amazon S3 and Amazon SQS, AWS SQS. So SQS, the simple queue service, and S3, of course, potentially one of the best things that AWS has ever created, which is a simple storage solution. Those products were launched in 2006 are serverless products. The future was there and we didn't realize it. You don't have to worry about how many machines or how much disk space you allocate for S3. It just kind of works. And SQS does the same sort of thing. But nonetheless, an awful lot of the attention around serverless focuses in on fast, especially for people who are building more complex distributed systems. And they're seeing the complexity that causes in the infrastructural space. And they're thinking, maybe this fast stuff is for us. And with function as a service type platforms, typically you're kind of abstracting away even more of the underlying platform. You're now able to focus just on your application, just on your function, and often even the operating system running inside that container is a concern you no longer have to worry about because the underlying provider is going to be handling that for you. And when we think about these stacks of abstraction that we get, and I've used this diagram before when talking to people about, the public cloud or the private cloud, and the public cloud, you see, offers you lots of different abstractions that you can engage at. You can work at the level effectively of virtualized infrastructure. You're just working with those low-level primitives. Or you can go to much more highly abstracted services like the serverless products. And as you go up this stack of abstraction, if you work at a higher level of abstraction, you get to offload more of your infrastructural work. And that allows you to spend more time focusing on building your product, right? So less time doing stuff, more time building cool stuff. Of course, as you go up, you often lose control. As you come down this layer of abstraction, you get more low-level access and a greater degree of control. The difficulty, of course, with any organization is like, how much control do you really want? Because with great control comes a lot of operational overhead in general. So every organization's got to find their balancing point. And increasingly, I find with a lot of clients, they're not really pushing themselves into trying the things that are higher up the stack. We should talk about function as a service very briefly before we start talking about how they apply to microservices, because function as a service platforms have some interesting limitations and interesting benefits. But we'll talk about how they work first off. The key thing here is you create a function, and a function here is a generic concept of a function. It doesn't have to be 5 lines of code, right? This could be 1 million lines of code, in fact, but it's just a unit of code which is going to be automatically launched based on some triggering condition. So you basically take your function and you upload it to the platform and you configure your function to say, when this thing happens, run my function. And that's kind of what you have to do. And then automatically, when something like an API call comes in, a message is received, a file is seen, you can even have these things trigger based on time, it will automatically launch a copy of your function. As more of those inbound triggering events happen, the underlying fast platform can scale up more copies of your function. You'll only pay while your function is being run. And that means if your function isn't being run, you're paying $0. As you increase the number of functions, you're paying more. So that's kind of just how it works. And that's kind of a bit quite different to maybe running permanent infrastructure, just sitting there waiting for something to happen and you're paying for running it. There are some limitations of function as a service. The first thing is that there are time limits on these. So for each function invocation, depending on the platform you're using, you may be limited in up to sort of, I want to say the latest limit on AWS and Azure is 15 minutes, but I could be wrong. But it originally was like 30 seconds. So they've been pushing those limits out. Still, if serving a single request takes you more than 15 minutes, fast might not be for you. Although I'd also then look at what your request is maybe doing if it takes that long. There are often restrictions in the number of runtimes. This is less of an issue now than it used to be, unless you're on Google Cloud. But certainly on Azure and AWS, you have quite a good variety of runtimes that are supported. And now they have abilities for you to run your own custom runtimes more easily. They are mostly stateless, as in you can't maintain state in a function invocation that a subsequent function invocation can make use of. This is a no shared state system. I'll caveat that by saying that Azure stateful functions are really interesting and you should look at them. And they basically use continuations to create function workflows. And I think it's an example of where Azure are doing some really interesting things that AWS just don't seem to want to do. You also tend to have limited ability in terms of how that scale up and scale down happens. That's kind of based on the internal rules and internal logics. And one of the big issues is just you're kind of baked into how the platform wants to give you information. Again, this is improving. Now, of course, there are solutions for running function as a service type offerings on top of Kubernetes. I would say in terms of server stuff overall, there are no good serverless databases that run on Kubernetes. There are no good service messaging products that run on Kubernetes, as far as I'm concerned. And both of that really comes down to storage. Storage is still a really hard problem. But there are at least function as a service platforms that can run on top of Kubernetes now. We've got OpenFaaS, which has been around for several years. And obviously Kelsey Hightower is a fan of serverless. And, when Kelsey has done so much for the CNCF in general and Kubernetes specifically, Kelsey's been, one of a number of people that have been agitating for more highly abstracted runtimes that would work on top of your own Kubernetes cluster. And of course, we've got Knative. So maybe in the future, you'll have something that looks like a FaaS platform running on your own Kubernetes cluster. Although now that the Knative has been taken out of the CNCF and is only being worked on by Google themselves, I have very little faith that it will be ready in anywhere near the time frames they're talking about. So anyway, you pay your money, you take your choice. But the idea is, you're worrying less about infrastructure management, more on delivering value. And like when I look at the promise of FaaS, I think it's the best abstraction we've seen for developer-friendly deployment of code since Heroku. And the vast majority of those developer-focused cloud products since Heroku came out have been focused on trying to copy Heroku. Heroku nailed the developer experience for deploying and managing code. Brilliant, absolutely brilliant. And, you saw so many things copy it, and FaaS is like the next one. I say all of that, right, despite the fact that a lot of the implementations right now are a bit crappy, right? I think the future has arrived. It's just arrived in a really beat up car. And I think, I'm hoping that we're going to see continued improvement in this space. Anyway, moving on quickly, let's talk a little bit about functions and microservices. How does FaaS and microservices go together? Can we bridge these worlds? And there are some misconceptions in this space. And also, I've changed my mind about how I view a lot of this stuff as well. So I wanted to update the things I share with you in this space. When we think about a normal microservice, and typically we're talking about a process-based deployment model. So if I want to deploy my shipping microservice, I might actually have multiple instances of that shipping microservice. And that allows me to handle more scale and also potentially to give me some degree of robustness so I can tolerate a node failing. Obviously, I'm probably talking to a database, and my database also may need some kind of backup mechanism in place. Maybe I've got a hot failover, or at least a lukewarm failover. When I'm thinking about scaling out my system like this and adding redundancy to improve the robustness of my application, one of the things I'm going to want to do is to distribute these different replicas and these sort of redundant copies across different failure planes. So if I was, say, deploying onto a public cloud, I would make sure that each instance of my shipping microservice would be in a different availability zone. Availability zones being kind of like the virtual data centers. And that's, if I'm managing things at the level of sort of a virtual machine and I'm spinning up those instances myself, I'm going to have to manage that work myself on my own infrastructure or something else. And there are variations on a theme, and arguably when you say look at something like Kubernetes, this isn't that much different really. It's just that Kubernetes is giving us nicer APIs for working with these things. And rather than those instances running on VMs, they're running on containers on top of Kubernetes machines. But fundamentally, we're sort of working with the same primitives. But in general, all those deployment models from sort of running directly onto physical hardware all the way up to deployment on Kubernetes, we have this idea that a microservice instance is sitting there waiting for something to happen. So it's sitting there, potentially chewing up resources, potentially costing you money if you want a pay-as-you-go model. But that's the kind of, they're all really shades of the same idea. They're all kind of variations on a theme. I'm there waiting. What's going to happen now? What's going to happen now? And of course, if you've got machines that aren't needed, they're potentially using resources and everything else. And yes, you can use auto-scaling, but that's not without its problems. So then, okay, we start thinking about, okay, well then microservices and functions, what if we use a function as a service platform, the idea that we can spin our microservice up and it's not running unless it's needed. Now, at this point, lots of people start thinking about functions and say, well, functions have to be quite small, right? Because I was told when doing, thinking about how many lines of code a function should have, it should have 6 lines of code. Therefore, I need hundreds and thousands of functions, right? And it's like, no. This is the problem with the word function being so generic. Function is just, think of it from a mathematical point of view, but fundamentally, from the point of view of a FaaS platform, a function is just a bundle of code that's going to get run when something happens, and an entry point into that function is going to be called, and that's kind of it. So the very first thing is, say, when you're moving into using a function as a service platform, especially for a microservice project for the first time, this is insane. Don't do this. Do this. There's no reason why you can't take an entire microservice instance and bundle it up as a single function. This is very simple. It's very straightforward, and it sort of keeps your distribution more limited. As you have more moving parts in a distributed system, they become more complicated and more difficult to run and manage. So this is fine, right? We still have a single deployable unit. We've drastically reduced the amount of infrastructural work we're going to have to worry about. And this gives you familiarity with some of the concepts you have around FAS and tooling. A sweet spot for this is often, I do encounter clients that have little microservices that do background administration jobs, and they're triggering these things via cron, right? They say, okay, we'll just hit a URL and you have some background jobs you're going to do. Those are the obvious ones to start with. Take one of those services, put it into a FAS platform, if you're in the public cloud, set it up to run on a time basis, and you've basically replaced that thing in a one-for-one style. Now, of course, the promise of function services, it does allow you much more freedom in terms of how you deploy code. And some people start thinking, okay, well, now I've reduced the cost of creating effectively and running my service. I can be bolder in running more. Often the reason people only have 2 or 3 or 4 microservices is because the cost and complexity of having more is too great. It's taking too much time, too much energy. But if I can offload some of the cost of creating a runtime and managing that runtime, I might be more bold in having more instances or breaking these things down into smaller pieces. Now, whenever I'm working with microservices, if we decide to break a microservice down into smaller pieces, what I try and do is practice this idea of information hiding and say, well, look, from the point of view of the upstream consumers of your microservice, they should sort of be unaware of the fact that you've broken this thing down into smaller pieces. So if we were going to take our shipping microservice and break it down into, say, 3 or 4 different functions, from the point of view of the external consumers, they should still think they're just talking to the logical shipping microservice. They wouldn't necessarily be aware of the fact that you've broken it apart into these different functions. So you need some level of indirection there. If this was a HTTP-based microservice, for example, this is quite easy to do just with some simple routing and like an API gateway or just a simple HTTP proxy. Why bother with this sort of artifice? Why bother with this degree of abstraction? It's simple, right? Information hiding is all about making it easy for you to change your mind and how things are implemented without breaking your system. In this situation here, you might pull your microservice apart into 2 or 3 little functions and then realize that was a terrible idea and you want to revert the whole thing. Well, if that change has been hidden from your consumers, you can merge those things back together again and they won't be aware that anything has changed. So this is all about giving you the ability to make changes in your system without breaking people. The next question then is, okay, well, if I can theoretically break a microservice down into littler functions, how do I find what makes a good, smaller scoped microservice? Now, I talk about this a lot in my books. Chapter 2 in Building Microservices, second edition, goes into this in excruciating detail. But one of the techniques I frequently use with the projects I work on is domain-driven design. And in domain-driven design, there's a concept called an aggregate. And you can kind of think of an aggregate as a collection of objects that you always want to manage as a single unit when it comes to things like state management. So the canonical example of an aggregate would be an order and its line items. You've got the order object. It has a list of line item objects in it. In a relational database, those things might be stored in 2 separate tables, probably with a foreign key relationship between the 2. But from a point of view of transactional state management, you'd always want to use and manage that aggregate as a single unit. And so when breaking these things apart, you don't want to split aggregates. So I would maybe use my understanding of aggregates to actually help find those boundaries. So that's just, kind of giving you a little bit of a tip if you're into domain-driven design. I used to say, well, we could have one function for each type of state transition on an aggregate, but that's a terrible idea. And I changed my mind and I regret ever even mentioning it. So the nice thing here is I could have a delivery service that just manages the delivery aggregate, for example. That's about as fine-grained as I go. And to be honest with you, I very rarely have actually felt the need to do it. But if you really want to go fine-grained, I thought I'd give you some little tips and advice. Let's move, and of course, we can push this further. Maybe we've taken our microservice runtime and we've now moved over to serverless for our function runtimes themselves, we can, of course, consider doing this at the database tier as well. There are a whole host of different serverless database offerings out there who promise all the same things around auto-scaling, high availability, pay for what you use. At this point, I will sort of just put a little cautionary note in. When you start looking at a lot of the serverless databases that are out there, they're quite different to databases you are used to. They'll have odd little difference in their semantics. And like running a function on a fast platform is not that different to running a container on your own infrastructure. But you don't really get to fully recreate the semantics of Dynamo or Cosmos in a different type of database. And often changing databases requires changing in the code. So switching database types is not necessarily something that's going to be zero cost to you. So just do be a bit aware there. And obviously the world of serverless databases is quite confusing in terms of like, if you have to start playing around with allocation units and all those sorts of things, it gets bewildering really, really quick. Okay, so what should you do about it? Here's what's Sam's advice? Well, I'm quite a lazy person. And people say, how do you get so much stuff done, Sam? And I say, by being very lazy. And what I mean by that is I make sure that I just don't do things I don't have to do. I find any reason to have somebody else do it for me if I can, because that focuses more time and energy into watching cricket and maybe writing books. So, this is my, mantra to all of you. The secret to getting more things done is to avoid doing things you don't have to do. This is it. Do less stuff. And this was the mantra that Amazon talked about internally when they built AWS. They wanted to get more things done themselves. They didn't want to have to screw around managing infrastructure. So they built the services that they themselves use, and now they sell to us because aren't they kind? Out of the goodness of their hearts, they just let us use their awesome tools just in exchange for just a small amount of money. But the idea here is to reduce your undifferentiated heavy lifting. What are the things, the work that you have to do that is difficult, that is hard, and yet fundamentally doesn't really differentiate what you do from anybody else on any other company? Is the work you're doing actually making a difference? This is the idea, build what's special to you, outsource the rest. If you want to go really deep down this rabbit hole of trying to understand what things you should do yourself and what things you should outsource in this way, I do encourage you to dive headfirst into the world of Wardley mapping, where Simon Wardley talks a lot about this. Simon Wardley, interestingly, a huge fan of serverless. And he lives down the road from me, although his internet's a lot worse than mine is for some reason. He's in the middle of a marsh, as far as I can tell. Anyway, this feels very scary. I'm suddenly going to have to give up huge amounts of control. If you're operating in an environment right now where you've never used public cloud or you've only dipped your toe in the water, going all the way into a highly abstracted service and using something like a fast platform just seems insane. And maybe don't start with something that scary. Maybe start with something a little bit easier. Coming back to that sort of abstraction stack I talked about, when you're looking at what the public cloud can offer, it's maybe not about saying I'm going to start at the top, where yes, I theoretically offload the most work, but I also give up the most control. It may just be about saying, if we are using the public cloud, where are we on this diagram here? And have we tried just stepping up a level? Have we tried using some of the more highly abstracted services and see if that works for us? I think, unfortunately, a lot of people are just settling for status quo. They're on the public cloud, but not really taking advantage of it. Or they're still kidding themselves that they can build an experience as good as the public cloud on their own infrastructure. And that, I do think, is a bit of a dangerous fallacy. So this is all about trying something. And if you haven't tried playing around with just function as a service, as I say, it's only a subset of the wonderful things that are out there, but just give it a go. Now, I sort of mentioned that a lot of the crop of fast offerings, some of them suck a bit. Some of the usability of the fast offerings is quite bad, I think. And I still don't believe that AWS really understands what developer experience actually is. They understand taking your money, but not necessarily nice experiences. So, there's work to be done here. There are sort of software development kits that can sort of take the rough edges of some of these fast platforms. The badly named the serverless framework, which makes it quite hard to Google for, is actually a pretty good attempt at this. And so I would say and this gives you like a nice way of sort of checking in your configurations that other developers in your team can make use of it. And it's pretty good. Don't necessarily buy the idea that it allows you to abstract away your underlying fast platform, because it really doesn't, but that's okay. So do take a look at it if you want to try. You could spend half an hour with this and have a function up and running and already play around with it. I'm going to leave you, though, with a final thought from Stephen O'Grady. So Stephen is one of the co-founders of Redmonk, who are the best analyst firm, I think, out there for developers and for sort of techies that are actually building software. Stephen was reflecting on sort of what's happened with OpenStack. And he sort of had this thought that sort of really resonated with me in the conversations that I've had with sysadmins and operations people and operations managers over the years. There are legions of IT staffers that will be protecting what they believe is their livelihood, the private infrastructure, at all costs. Unless technical leadership is willing to wage total war on its own infrastructure, then private infrastructure will continue to be a thing. A lot of us are trapped in this cycle of, we've got machines, we should use them. Well, let's build a private cloud to make use of our machines. Great. Why are you buying more machines to run your data center? Oh, because we've got a private cloud. But the only reason you've got a private cloud is because you already had machines. So because you had machines, you built a private cloud. And now because you've got a private cloud, you're buying more machines. Maybe think about breaking that cycle a little bit. Maybe really ask yourself the question, am I really one of the people that has to have their own private cloud? Maybe you are. Maybe you've got specific restrictions because of government, local government or regulatory restrictions. Maybe you've got political concerns around the problem around, sort of the hyperscalers. Maybe you're an activist and you're worried about your data being in place it shouldn't be. And there are some legitimate concerns out there. But for every 10 clients I speak to that have concerns about this stuff, when you get down to it, very few of them can actually explain a really good reason why they don't want to do it, other than we've already got machines. Anyway, I've got time for questions, I hope, but there's loads more information out there about what I do. You can find earlier versions of this talk available in video form on the internet. There's also another talk there called It's a Trap, which goes into more detail about some of the challenges of private cloud, which might be of interest to you. You can find that in the talk section, along with information about how you can get hold of the second edition of Building Microservices, which is available electronically now and maybe in paper copy if you're luckier than I am. But I think that's it. I think we've got some time for questions, I hope.